These are the examples for Algebra 2B, Credit 5, Lesson 23.3. Lesson 23.3, we're going to be talking about something called standard error of the proportion. And we're going to see it's something that can be used in a manufacturing environment to make sure maybe that our machinery is working correctly. And well, in this case, we're going to see our problem is talking about prizes in a certain percent of boxes of cereal. And we want to make sure we're being honest and we're giving out as many prizes as we say that we're giving, but not too many because we don't want that could cause us to lose money. All right, it says a different popcorn manufacturer puts a prize in 20% of its boxes of breakfast cereal. When sampling from this population, consider successes to be bags of popcorn containing a prize, P equals 0.20. You choose a random sample of N equals 300 boxes of cereal. In our example, we want a prize in 40% of the boxes, so we're being a little bit more generous. So 40% as a decimal is 0.40, and that's all. They say P equals, in the problem, 0.20, or in this case, P equals 0.40. It's just this percent written as a decimal. And then our sample size, N, is going to be 700 boxes of cereal. All right, so let's go ahead and substitute now into our formula. So the standard error of the proportion formula is the square root of P times 1 minus P over N. So P is 0.40, and then times 1 minus 0.40 is 1 minus P, and that's over N, which is 700, number of boxes in our sample. So now we have some simplifying to do in our numerator, I should say. So starting with our parentheses, following our order of operations, 1 minus 0.40 is 0.60, and then over 700, and then multiplying 0.40 times 0.60, and we'll come up here, I believe. That will be 0.24 and over 700. So we've simplified our numerator, and now we're going to divide that out, 0.24. So remember, the fraction bar means divide. So 0.24, you enter that first, divided by 700, and we get a very small decimal. We get the square root of 0.000342857. So we're not rounding yet because it's not our answer. Although it could be safe to round to a certain place, but it's just better to not round, and you don't take the chance of getting skewing your answer from what it should be. All right, so now we're going to take the square root of that number, and we get 0.018516402. But as you can see by your answer choices there, they're rounding to 3 decimal places, and so we'll do that in our example. So we're going to carry it out to the 4th decimal place because we need that 4th place to tell us how to round. Now remember, when we're rounding, the options are to stay 8 or go up to 9. For that, we look to the next number, which is the 5. Remember, if the next number is a 0, 1, 2, 3, or 4, that's a stay number. 5, 6, 7, 8, and 9 are the go up numbers. Since this is a 5, we are going to go up to 0.019, and that would be our standard error of the proportion written as a decimal. Now, problem number 2, it says for a random sample of 300 boxes, or in our case 700, what interval captures 68% of all sample proportions under the normal curve? So the first thing we're going to have to do, since we're doing this as a percent, we're going to have to take our 0.019 and convert that to a percent. Remember how we convert a decimal to a percent? We just move it 2 to the right, and so the decimal is now here, so that would be 1.9%. 0.019 written as a percent, 1.9%. So we have 40 plus or minus 1.9. So that's how you do that. Your 40% plus or minus whatever your standard error of the proportion was written as a percent. So on the low end, we have 40 minus 1.9. And on the high end, 40 plus 1.9. 40 minus 1.9 gives us 38.1. And now we'll put in the percent symbol. And 40 plus 1.9 gives us 41.9%. So if our machines are working accurately and correctly, we would expect 68%, about 2/3 of our samples, to fall, the prize in the box to fall within this range between 38% and 41.9%. And again, some of the samples could be below that, some of them could be more than that. But again, if everything's working correctly, we would expect about 68%, which is about 2/3 of the time, a prize to be in 2/3 of the time between 38.1% and 41.9% of the boxes in our sample to contain a prize. All right, so let's take a look at one more sample, or one more example. I guess sample is an appropriate word for this, isn't it? So one more example of this, and very similar calculations, but just to kind of go over it one more time. So the example in the next page, page 42, says, again, a different popcorn manufacturer puts a prize in 35% of its bags of popcorns. When sampling this population, consider successes to be bags of popcorn containing a prize, P equals 0.35. You choose a random sample of N equals 100 bags of popcorn. All right, so let's go ahead. This will be our example for number 3. We're going to have a prize in just, now we were a little more generous in the last example, but in this one, instead of 35, we're going to go to 25%. So prize in 25% of the boxes, which means P, 25% as a decimal, would be 0.25. And then our sample size here is going to be 50, so just 50. All right, so let's go ahead and put our standard error of the proportion formula up here. P times 1 minus P over N, and we're taking the square root of that. So P is 0.25 times 1 minus P, which again is 0.25, all over N, which is 50. All right, so just like the last problem, or like we did on problem 1, I should say, we're going to simplify using the order of operations in our numerator. 1 minus 0.25 is 0.75, and then over 50. And then multiplying our numerator to finish simplifying it, we got 0.25 times 0.75, and we get 0.1875. So we'll come up here. So we have 0.1875 over 50. And we divide, fraction bar means divide, so we're dividing 0.185 by 50, and we get not as long of a decimal on this one, 0.00375. We're going to take the square root of that number, and we get 0.061237,244 in case you're working the example. But again, we only need, we're rounding to the 3rd decimal place, I believe, once again. Yeah. And so we only need to go to the 4th decimal place. So 612. There we go. All right, so our answer is this. Now we need to round 0.061. The next, so we can either stay 1 or go up to 2. The next number is a 2. Remember, 0, 1, 2, 3, or 4 are stay numbers. So since the next number is a stay number, we're going to stay 0.061. And so that would be our standard error of the proportion. So now our example for number 4, we're going to have our 25% plus or minus our standard error of the proportion. And we need to write that as a percent. So we're going to move that decimal 2 places to the right. And so that's going to be 6.1%. So we have 25 plus or minus 6.1. So on the low end, we have 25 minus 6.1. And then on the high end, 25 plus 6.1. So we subtract 25 minus 6.1, and we get 18.9. And we'll put that as a percent, not round it, but write that as a percent. And then adding 25 plus 6.1, we get 31.1%. So once again, interpreting what this means, if our machines are working correctly, we would expect 68%, about 2/3 of our samples, to fall within this range. In other words, 2/3 of our samples, there would be between 18.9% and 31.1% of the boxes would contain a prize. And that's how we would interpret that. All right, those are the examples. As you can see, 3 and 4, very similar to 1 and 2. Again, pause, rewind, a very interesting concept and application because, again, if the numbers are too low, if you're getting less than significantly less than 2/3 of the prizes in this range, then you're not really doing what you're telling your customers you're going to do, have a prize in that percent of the boxes. And if the numbers are higher, then you're maybe spending more money than you need to by giving away too many prizes. So it kind of one of those important concepts that translates into the real world. All right, so that's it for this video, and good luck with the work, and I'm sure you're going to do great with it. So that's it for this video. So until the next video, take care and God bless.